voice is starting to go out. I've been on the phone so much today. Well, gentlemen, we're going to continue on. This is What's in the Big Giant Box BBI series, where I just randomly pick one of these giant boxes I have sitting over here, storage, and we just fix it, or give it a shot anyhow. This is an old Tokyo High Power. I remember this guy calling me now. Vaguely. Cool. Send me all the paperwork. And it's in the original box. Giggity. Let me get this dug out of here, and give me just a second, but we'll be right back. Talk about very well packed, my God. Okay. I respect that. For as much as this thing is worth, I really respect that. Okay. Purchased from a Silent Key. Had two. I missed the working one. I also have the THP 1.5. He's got the bigger one. But I don't think that matters. The legend goes that all functions seem to be working, including the high voltage. There's no high voltage in this thing. But when unload is applied to the amplifier, the overdrive protection light comes on and no output. Must shut the amp off to reset. The amp had 4 new SD2933s, otherwise known as... This could be the MOSFET version. I'm not going to speak out my butthole yet. Let's see. Not sure if these are cheap aftermarket finals or if they come with a unit. This unit's exceptionally clean, cosmetically and inside. Want to get repaired. Opened up for... I don't know if we're going to be able to do that. He wants to know if he can get it for all the bands. And we'll see. I realize this affects the value, but for what it's worth, I do both ham and CB, blah, 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 blah. Okay. I do believe that this is the full, almost full legal limit MOSFET version. So let me get it unpacked and all the other identifying accoutrements removed from the amplifier, and we'll start there. Now, if memory serves me, which the last one of these I had in here, it was a little particular in how you wanted to have everything set up. So put this on manual. We've dialed up 80 meters. We have on this power display, we have it in operate. And we're allowed to go into operation mode without it tripping. So over here, what we've got going on our units of measure is a, let's see here, 50 watt slug in forward. This damn camera's gonna be the death of me, I swear. Okay, there we go. Give the camera something else to focus on. It's a 50 watt slug going forward. As you can see, the meter movement says 2 through 30 megahertz, 2 through 30 megahertz, 2 through 30 megahertz. So we are just on the bottom end of the scale. For the frequency, we're on 80 meters. And we're going to look at this far right one first. Let's put this in standby. We're going to put 2 whole watts of power into it. So with a 2 watt carrier on AM, let's go ahead, we'll step on the foot pedal. And we have 0 output power. Nothing. Radio, amplifier, nothing. Go back up to 80. We'll run our drive power up a little bit more. Let's see, so I'm reading that middle scale. So we'll put 5 watts of power into it. It's trying. I think we might have ourselves a case of blown finals here. Let's take and run this up a little bit more. We'll put 10 watts of power in it. Yeah. We have no input reflect. Power supply is coming up. Okay. Well, let's take it apart and let's find out where the RF is going to ground. And I have a feeling that it's the finals. Well, we got this stripped down, case is off, and the beauty of this amp is the people at Tokyo High Power gave a shit when they designed it, right? Today, with the engineers that we have today, they would never think, oh Lord, we'd have to take that apart. I see a couple things in here I don't really like. And it all came apart like it's been apart a couple times. So let's see, what do we got in here? No, we've got legit transistors still sealed in their bags. And this is the MOSFET version, by the way. The 50 volt MOSFET version. Not LDMOS, MOSFET. Big difference. Okay, let's see what the circuit tells us just with a little visual inspection. MOSFETs. They look like a 2879, but they ain't. These are much bigger. Let's go down in here and we'll just take a slow walk through this thing. Now, does that look like factory grade soldering to you? Yeah, it doesn't to me either. And all this solder flick down here, that's kind of got me concerned as well. So, this is our input attenuators. Now, they did a beautiful thing. They mounted this down on a spreader. But our RF signal comes from our filtering board PA switch through this wire, passes through the attenuators, comes through this wire, goes through our input transformer, and we've got 2 and 2. So we've got 2 units here, 2 units here, and then it goes to our output transformer and then goes out through this piece of coax through this BNC. Now, this is our singular flyback. This is our balance. This has been apart. Somebody has taken this apart and tested something. We don't know. We don't know if they've tested the transistors. We don't know. But we know by looking at the solder work, which my friggin' 16-year-old kid can solder better than this. Of course, she's got me as a dad. So this solder work here tells all. And this here. This here and this here. So it's one of two things. The transistors got pulled out and got tested, and they tested good. They put them back in the amplifier and it didn't work. Or they test bad and they put them back and soldered them back in the amplifier for some reason I don't know. The other thing is these are our fuses, and this is what brings our 50 volts DC into each one of the transistor sections. And the idea is if this MOSFET pops open to help protect the gate circuit, it overloads this fuse and goes open. Those fuses are still good. So, I propose that there might be another problem going on. Like maybe the RF isn't getting to our input section over here. Or maybe there's a problem with our attenuators. Or hell, there might be even a problem with the relay. I would like to believe it's all of those things, but in the same breath, how we're going to cover our asses, we're going to pull this N transistor right down here. We're going to pull this one out. We're going to put it on the Atlas and check it. I mean, that's the least we can do. It's nothing to pull this transistor out. It's 2 screws, a dental pick, and about 5 minutes worth of time. And that'll tell us which direction we have to head. Hopefully it's a bunch of blown transistors. And that's all we got to do is change out 4 transistors and I get to send it back to this guy. But knowing Tokyo High Power and the way they engineered things, it's going to be something a little bit more complicated than that. But, like I said, thank you to the guys at Tokyo High Power that put this together like they have a brain in their heads and made it so that we could just simply fold the PA section out and lay it on its side. And I think we're going to pull this completely out for me to do the work. A little disconcerting to me, the amount of solder spall that was up underneath the board. I took the dental pick and just swiped around underneath here and started pulling just all kinds of stuff out from underneath the board. Which tells me whoever was in here last honestly didn't give a shit. So it's okay. We've got better technology. We'll take care of it. We will take care of it. All right, I don't want to scuff up that copper, so. Okay. I got to give you guys credit. The last one of these I worked on, I had I had 3 gentlemen reach out to me and talk to me about it. That was the one that was involved in the lightning strike. And I was so grateful that the guy sent me the book that comes with this, because it had to that unit's spec data sheet, or not data sheet, but schematic. And I had 3 dudes that come alongside that are incredibly brilliant, smarter than me by a mile, engineers that said, well, did you check this? I was like, yes. Did you check that? I was like, yes. And then I was like, well, wait a minute, I can't check that because it's not on my schematic and it's not in this circuit. He's like, well, it shows it on my schematic. I live to find people like that that are willing to help. So please don't think when I speak, I come across sometimes as like, I know everything, I can't learn anything, but that's not the case. I'm always open to learn something new. And if you think that I've missed something in my little analysis of stuff, come talk to me about it. Come talk to me about it. I'm always looking for new teachers. I am always looking for people that are willing to help me or teach me something new. And when it comes to some of this stuff, I'm flying in the dark. Now this is pretty simple. Got a power supply, got a filtering circuit, meter circuit, fan, our band filter, band pass filter, low pass filter, whatever you want to call it. I had one guy that just come unglued on me on this last one, the Worthmore that I worked on, because I used the wrong terminology. Just about creamed down his leg. He's, oh, I got BBI now. I got him over a barrel. And so when I came back to him, I said, now, is it more important that I grasp the general idea of how the circuit works without a schematic, and I did the repair and got the unit back up and running? Or would you rather me be more specifically paying attention to terminology? I said, I'm open for the discussion. And we did this on the video. The next day, and that's why I told him, I said, you're more than welcome to talk with me about it. You know, it's not that of an important thing to me. I just kind of wonder about these people that wheeled in on their high horse and they're like, you used wrong term, therefore everything you did is no good. It's like, no, dude, that's not how this works. Over here in the land of reality, that's not how this works. The next day, I went to go see if he'd followed up with me on any comments. He took his whole comment down, which I thought was a shame, because some of the stuff that he had shared in his comment was actually educational. This is testing as a good MOSFET. Its gate voltage is remember this, 2.3 volts. Okay. So that tells us that they pulled the FETs and then they tested them. Now I just blew the seal off of one of these packages. So the owner of this box, you can hate me for it later, but I'll sign the bag or something to make it up to you. Remember, transistors work or they don't. Period. Especially MOSFETs. N-channel MOSFET, 2.2 volts, same millivolts. .1 ohm. I got to check that, recheck that. I don't remember what that was. It's 0.1 ohm. Yeah. Okay, let's recheck this. Let's put these little delicate gems back in their anti-static bag. Delicate little gems. This is an incredibly mass manufactured component. The last time I looked, which was about a year and a half ago, 2 years ago, you could buy these for relatively like $5 or $10 a piece. Really cheap. Gate voltage is pretty high though compared to the other component. Pardon me, 1.0. It's the same. These are the same parts. Okay, so these are legit. These are legit. Go back in the box. Okay. So that tells us either by the magic of God I pulled the only good transistor out of here, or there's something else going on. So let me bypass the safety interlocks. I want to sweep back through it and make sure we don't have anything shorted out because of some of the wonderful, tremendously wonderful solder work that we have in here. Like I was saying. The board is full of this, so let me go back over this. I'll put the transistor in. We're going to clean this pill pocket out. We'll go ahead and we'll clean this pill pocket out with a Q-tip, and we'll clean the base of the transistor off. We'll get some more electrical heat conductive schmoo material put in there, the white sauce, and reflow some joints, and then we've got to actually do an in-amp test. I got to put power to it, and I got to make sure we're getting gate voltage is coming on. It's could be another thing that's gate voltage could be way out of whack, or that circuit could not be working. So let's go down the rabbit hole, Alice. Okay. This resistor right here is screaming hot. So's this one here. Transistors are ice cold. We're putting a ton of power into them right now. And the attenuator, that's part of the attenuation circuit. The reason that's getting so hot is because all the RF that isn't getting amplified is backing up into that resistor. Okay. So we had it working for a second. Just for a second. And it's when I applied pressure to this MOSFET right here. This resistor, its paired partner on this transistor, and the resistor here and here has also been changed, which tells me this thing has had a failure. I've got signal coming into the transistors. I got gate flop, and I know from here out is good because I can disconnect this BNC, which I don't want to do right now because there's power on everything. Knowing my dumb ass, I'll drag it across the output transformer or something. Disconnect that BNC, and I can inject a signal, and I can pick it up the rest of the way out of here, all the way around and over to here. So something is pulling down, and we tested this one. We know it's good. I reflowed this one, solder wicked all the crap off of this one and reflowed it back on. Solder wicked all the shit off of this one and put it back on. What I want to do now is I'm going to pull all of these out of here. There's got to be one of these that's bad, and it's pulling the whole thing down. Because this does work in kind of a push-pull configuration. I mean, push-pull. These two transistors run in parallel, so if this one of them goes down, it's going to, that would show up as heat, as imbalance. And I'd be able to see the transistors flare. When in doubt, pull the MOSFETs out. Mystery deepens. I go to pull the screws out of the transistors, and they are just barely in there. This one here It's got a big old blob of solder shit directly underneath the transistor. And the thermal compound, wow. Come on, I gotta be dramatic for camera. The thermal compound is completely dry and it's just full of little balls of solder. So I don't understand what's happened here. It's like somebody, and it's just full of dirt. It's like somebody took this all apart and then slammed it back together and said, no piss on it. But then why would you bother putting the transistors back in it? I don't... This one here, a giant flake of black shit underneath the transistor. So, I don't know. This transistor in itself speaks volumes. I'll show you that here in a second. This pill pocket is once again full of just garbage. Solder flick and all kinds of hard stuff. Just is scary to me. Okay. Let's do our dental pick sweep. Oh yeah, here comes more solder shit. That's different. There's a hard obstruction right here. As I sweep the pick underneath here, there's something very hard hanging down that the pick's getting into. Same thing going on here. This resistor might be shoved through and it shouldn't be. It could be making contact with the heatsink. Same thing going on here. Yeah, we're gonna have to lift this up and look down this edge, but I digress. Let's go look at this. This gets even more interesting. These are taken out in the order that they were in the amp, right? Okay. Looks okay. Just outside cursory inspection. That one looks all right. But this guy, it's had some welding going on. And a ball of solder. And even more welding. Look at that. It's on the ground lead. That's on the drain side. See, gate source drain, yeah. So, this is our problem child, by the way. MOSFET. If that one tests good, I don't care, I don't trust it. MOSFET. No way. No way, hose bag. No way. It's telling me the gate on this is 2.37. I'm only seeing half a volt. I don't believe it. I don't trust this component. There's something defective here. I mean, that's welding. Straight up welding on the end. No. All right, well, let's go see what's hanging up underneath here. Well, here we are the next day. I went in the house and ended up spending time with the wife. And okay, yeah, you guys know the rest of the story. This is our problem child section. Pardon me. Yeah, this is our problem child section right here. So we'll flip it over, and we'll see that this is the combination of through board and surface mount technology that they had applied here. What do we see right here? See that? These are called solder vias, and they have them on everything but the input side. This is a hot 50 volts. Well, these transistors have been soldered in and out so many times that the solder vias are starting to drip through. So I'm going to come back with solder wick, and we're going to clean these vias up and make it so they're not hanging down and shorting out like this. But I still don't feel that this is the problem. Today I'm going to remove these flybacks. This one broke off from being moved around so much. So that means we got to pull these flybacks out. And let me just first say that this whole circuit's very cool, and I'm going to take a ton of notes on it. I really like how this particular PA circuit's set up. So we're going to pull these flybacks out, and then I got to get in the manual, and I got to find out what the exact value of this resistor is, this resistor, and then its paired resistors that are underneath here. This one here. Because you can see there's one on every one, and I don't think this is the right value. These have obviously been burned up at some point or another. And I want to check, because these have been really hot, I want to check the value of these resistors as well. I'm also going to take the opportunity to check these blocking caps and make sure they're within value. There's quite a few things here I just want to go over real quick, because I have a pretty good feeling that our problem is going to be in these resistors or up in this capacitor. And since I have this board out, it allows me to have access to this side of the board, and I can go in and I can solder these resistors in properly. These are soldered on the surface, and they need to be soldered through. And it literally looks like they cut the leg of the old resistor and then soldered to it, like they're soldered in a keying circuit for a Texas Star or some bullshit. I'm going to pull this last transistor out and set it aside. I'm going to put this whole mess back together. I'm going to remount it up onto the pallet, and then we're going to put the PA section back in the amp, because I want to see what my gate voltage is set at without the components in play. That 0.5 volt gate voltage is entirely too low. That doesn't sound right to me. It doesn't compute to anything, and I want to find out if there was something on here that was pulling these down. If there was a resistor that was going open and it was pulling a gate voltage down. Like I said, I'm not going to reuse these transistors because I have zero faith in them after seeing what this thing's been through. Could have been something leaking inside the transistor and it's not showing up when we put it on the Atlas. I don't know how many times I've seen that before in my life, where the Atlas says, nope, good to go, especially on a MOSFET component. And then you go to put it in circuit, which is much higher voltage and much higher current, and then something goes wrong in the transistor. So that's how we're proceeding forward today. First, solder work. Second thing, flybacks. Third thing, let's verify these resistors. Fourth thing, I've got in-circuit surface mount tweezers, and I'm going to go in and I'm going to check all these caps because I have zero faith in them. Okay. So we're going to start out over here showing the schematic, and I want to explain a couple things. Anything below 1,000 ohms worth of resistance is just designated by a number. How do we know that? Let's look here. Let's look at R222A. That's a 12 ohm 5 watt resistor. And that's this resistor on the board right here. Okay. As we can all tell by looking at the color code, brown, red, black, okay, 12 ohms. This is a 5 watt dissipating resistor. So, we'll come back over here to the schematic, and we're going to find that this here is 10K, this resistor here, and that is this blue resistor right here, which we can tell by brown, black, black, red is 10K. Okay. So now, let's go look here. Green, blue, orange, gold. 56K, if my memory serves me correctly, which it doesn't. It's a resistor 113 or 213. That's right here. Look at that number. 47 ohms at a half watt. $55K, 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 $55K. Now, I know we're in circuit, and I know that this is not the best way to test this, but once again, 10K. $55K. There's very little difference in my mind between 57 ohms, or pardon me, 47 ohms and 55 ohms. But there's a night and day difference between 47 ohms and 56K ohm. It's a huge amount of electrical difference. So I think somebody read this wrong. And when they popped whatever happened in here, they put the wrong part in here. So I don't know necessarily if that's what's causing the problem, but we know those aren't the right parts and they can't stay. This is how much solder wick. I can only tell you how much stuff I sucked off of here with the solder sucker. But we're going to go wash this here in a second and make this look like new and get all the flux off everything. First I got to go hunt down some 47 to 50 ohm resistors that aren't massive, because everything I got that's 50 ohms like a 5 watt, and that ain't gonna work. So let's go hunt these down. We'll very carefully remove these and reinstall them appropriately, which is through the board. But God, I love Tokyo High Power. Everything's just straightforward. It is what it is. So and for those guys that want to follow along, found this makes a huge difference. When's the print date on this? Like I've said several times, there's multiple different schematics and there's different rev versions of each schematic. Here. The H18.2 or 12.10 is the version for this. That's the schematic we're working with, and this is the manual that goes with the serial number on this guy. So, okay, let's go find some resistors. I was doing a video hamfest one time with one of my friends. His name's Zane, and there was this guy who was unloading a rack of resistors, you know, parts organizers, and there's about 10 of them. And I said, hey man, walk over and look at those for me. He walks over, and I said, damn, all them goddamn drawers are full and they're all labeled. And he goes, yeah. I said, ask him how much. And he goes, how much? And the guy said, $20 per unit. And I said, cool, I'll take them all. My friend Zane goes, good God, why? Now, my friend Zane was kind enough to load all this shit up, take up half of his van to fill it up with resistors. And then my other friend Rodney, we call him Rodan, he's a big ham radio operator, was kind enough to load him up in a semi and bring him up to me. Now, I've got him sitting down there at the end of my shop. And they're all held together with pallet wrap. Well, they're not anymore. Big old stack of these damn things. In that organizer is every valued resistor that they ever made. First it goes from like 1 point something ohm. It's like 1.1 ohm. And it goes all the way to a meg. And it does that in half watt, 1 watt, 2 watt, and 5 watt. So each drawer has got a significant stack of resistors in it, but quarter watt or half watt, 47 ohms on the button. It just took a half an hour to dig down to get them out. I have dreams of mounting them up on a wall and I can just walk over and pull parts out of the bin. And 47. Some of them say 1% and then some of them say 5. 47. I'll take this as a win, and it's the right wattage. I just want to publicly thank my friend Zane for allowing me to get the components, and my friend Rodney for bringing them halfway across the United States so that some poor guy out there that I'm sure is dead at this point, it's a silent key of some kind, accumulated these things. And now they're coming here to go live in this thing. I think it's awesome. So let's get to pulling resistors and getting the right parts put in here. It's the details in life that get you. I swear. That was a lot of fun. I just finished. Now, this amount of solder paste that I just put down is more than enough to do this whole thing. This is the final PA transistors. Input attenuator. Okay. One little decimal place. Well, 2 little decimal places means the difference between a lot. But I was just sitting here thinking, it's the details that matter. It's the details that matter. There we go. Give me this. Give me this. Needless to say, the board is fully repaired. It's time to start taking the steps to put it back into the amp. Now, I spent a little bit of time looking at all our other resistors and checking a couple of the components, and for right now, short of these being so hot from us having to do the repair, I feel fairly confident that this thing should take off and run now. But yeah, we cleaned up both sides, cleaned all the flux off of it. Legit through hole soldered. I mean, like I went through and I dug out all the remnants of the old resistors. That all came out. Didn't sacrifice the quality of any traces because there's stuff that hooks up to both sides of those. So we washed the pallet, and the only thing I got left to do is to mount this down. But before I do that, I got to reinstall the flybacks, which go from here to here. So I got to reinstall the flybacks, mount this down, then I'm going to hook it up and I want to run it, and I want to take some volt measurements off of it. But that took quite a little bit of time, but it's repaired with the right components that are all less than 1%. So, yay! Remember this test I'm going to perform from earlier, where it was showing us 0.5 volt on our gate. Okay, ready? Oh, 3.5. 3.5. 3.5. 3.5. Now it's going to change a little bit as soon as we put the part in there. But now there's enough gate voltage to actually turn on the component. I'll say that much. Before I run away and just slap parts in this thing, get all excited, I'll pull a data sheet and I want to see what the actual turn on gate voltage is for those. Well, according, it's a man, this is a good part. HF, VHF, UHF transistor. Let's see. Minimum gate is 1.5 and the max is 4. So shut this off and let's install some new parts. Fly back. Okay, ready? Watch. What we're seeing is the transistors come on and go to idle, which is something that didn't happen before. And right now, with the components in the amp, .5, 3.4, 9, 3.5 basically. 3.52, 3.52. Transistors are turning on and they're saying, okay, inject signal into me. I am very confident this is going to work. If not, it's going to catastrophically fail in giant pyres of smoke. Let's see what happens. Okay, now we got everything set up to test. Let's run through our test platform. This is a 50 watt element in forward, 1000 and forward, 1000 and forward. Okay, so the 50 watt element is what we're going to use our base line. Now, we're on 80 on AM, and down here on the face of the amp, we're also on 80. Okay. If it makes any kind of power, we're going to call this a win, which I know it will. We're going to put, now remember we're reading this middle scale and we're looking right here. So 50 is the max meter movement on this thing. We're going to put 2 watts of power in it. Step on the pedal, go into operation. 2 watts of drive, 10 watts of power. All our transistors are heating up evenly. Show this to you with it in operation. On the pedal, on the key. That's not unreasonably hot. Uh-oh. You know, I forgot to do one thing. Retrim the gate voltage down to 2.2 volts. Whoever it was has been in here and they've twisted all of these adjustments. This one, this one, this one, and this one. The gate voltage is too high. The transistor's turned on too hard. As soon as we started asking it to make power, this transistor shorted and this one shorted, but it's shorted in such a way that it's letting 50 volts backfeed. And guess what? It burned up our 47 ohm resistor, which sits between the bias circuit and the gate. So guess what? This whole thing gets to come apart. So I can change out this one resistor, and then I'm going to lift all the gate leads on this thing. So can't do anything. And we're going to adjust our gate voltages down. Thank God these parts aren't very expensive. Okay. Getting tired. A long day. Been on this box all day. And I have just spent the last 2 hours trying to figure out all the different adjustment points, and I had to check all of them. Let me explain to you why. This is the stock PA that's out of my personal Tokyo high power that I have. I have one of these. It sits in a closet along with a lot of cool other stuff. And I thought to myself, wait a minute, I got one of those. So I ran up in the house, pulled the case off of it, set it here on a workbench, and ran it on a workbench, and my gate voltage was 2.7 volts on the gate. So now there's a couple different things that you can adjust here. These potentiometers here are our fine adjustments, and this is our coarse adjustment. So I took and adjusted the fine adjustments in at first, and let me show you where we're at now currently so you know that we're not doing anything stupid. 2.9 or 2.693, 2.697, 2.9, and 2.93. Okay, so we're 2.69 all the way across the board, give or take 1/100 of a volt. For now. Silly me, 100% my fault. I did not check the fine adjustments or the coarse adjustment. The coarse adjustment was so high that it was causing a power fault to show up here as an OV. So every time I put it into transmission mode, now that I finally got it working, it would go into overprotect. Now, we're on 160 meters. And we're going to primarily pay attention to this 50 watt element. So, hello, 1, 2, 1, 2, 1, 2. So we're swinging about 5 to 8 watts worth of RMS power into it, about 16 watts peak. Hello, hello, hello. We are making good power now. Let's go over here. Now we're looking at everything in average. Turn on a peak kit, and we'll be on the 1,000 watt scale. Okay, that's been a challenge to get this here, because the guy that had this before me was Scrooby McTurneveryknob. Idiot. Hello, hello, hello. Making 160 to 180 watts of power with less than 10 going in. The RF section is working fine. I did some quick little retarded math. These are our finals. I'm going to step on the foot pedal. Our bias is fully engaged. We're not making any heat. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Transistors are working perfect. This is all fixed. Part of the problem was that when I put this back together, the second time, I bolted this down. We adjusted some stuff here, and the flybacks, the traces that hold the flybacks in place are paper thin, and they folded down, and the legs of the flybacks actually were making contact with the copper board. I didn't catch that. So between that, taking the input signal and running it right to ground, the gate voltage trying to overcome that short, and the gate voltage being a full volt too high, is what caused that transistor to fail and that one to fail. So, learning, and we set up all of our gate voltages now based off of what we read from this board here. I understand that about 2.7 to a max 2.9 is right in the right classification for full crossover, Class B or AB1 in FM mode. Now, that being said, as soon as I started putting out power, and now it's deciding it doesn't want to do it, and this is the thing that I've got to thoroughly test is this adjustment, the PR. When I first started running this, it kept tripping, telling me that I had too much reflected power. It was showing a lot. That's our volts. Okay, so let's look at the meter on the front of this thing. Hello, 1, 2. Hello, 1, 2. Hello, 1, 2. That's our forward power. There's our power reflected. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. It's not showing anything. A few minutes ago, it was showing me 50. And what I can't help but notice is, once again, the witnessing marks that are back here on this board, on this back wall. This is our power meter board. Those witness marks have been messed with. Like somebody's gone in there and they've adjusted something. So, I was looking at the manual. I was thinking about how I could go about doing a calibration process on the reflected output meter, which I think I've got that figured out. I need an antenna tuner and my dummy load. But I've had to adjust all of these potentiometers here. This one here. This is our balance indicator, our power forward adjustment, and power reflect adjustment. And this one here has been fudged with, and so's that one there on that board. And I'm glad that they bothered to give me the manual. This is on the, to adjust these, I have to take the faceplate apart, and I don't want to have to do that. Hopefully we can be able to get it to come in by taking a reflected adjustment here and getting it dialed in. But final section is put back together and working. Let me do a couple more adjustments to this thing. I'm going to take some measurements off my own personal Tokyo high power and reference the measurements in here. And we're going to test it again. We'll be back. So let's talk about how to Mars mod this thing. Now this amplifier is going to work everywhere. It's going to make about 1,000 to 800 watts everywhere, except for the 27 megahertz band. Now, if we go and we refer to the manual, there is one small description in the manual on one page, and it talks about jumper A and jumper B, or jumper 1 and jumper 2. Jumper 2 is the disable for 27 megahertz. So to fully Mars mod this amp, we take jumper A off and put it on, or jumper 2 and put it on jumper 1, because jumper 1 is no longer, it's not utilized for anything according to the manual. It is now fully Mars modded. It should technically work everywhere. Period. This is how you Mars mod a Tokyo high power HL-15K FX. Just so you all know. I think I got it. I think I got all the little bugs worked out of this finally. I'm grateful that I have my own version of this. Let's unplug this actually. Had my own version of this to look at as a reference, so that I actually could measure most of the settings. The guy that was in here before me twisted every frickin' potentiometer, just like every goddamn thing. But this is what happens when you just persevere. It's like I told the guy that owns this thing. I said, man, I'm ending this day knowing more about Tokyo high powers than I knew at the beginning of this day. So, ending the day more than what I knew when I woke up. I want to throw some screws on this thing. want to run it through its full paces. So I want to make sure that it's got good airflow through the heatsink. Because after watching how this PA section works and operates, having air come out of that port is really freaking important. It's a neat system that they have inside this box. Air flows in and it goes through over all the vital important components. And the way they have it set up is it kind of swirls and then dumps out here. So it gets air on all the places it needs to have air before the main bit of the work is done, before it comes through the heat sink. I love the whole spreader thing. Now, I wasn't going to give up on this. I wasn't going to quit. I wasn't going to stop, and I didn't care. I want to make this work. This is such a well-designed piece of equipment. This is not one of those things where you go, well, you know, I don't think this is really worth repairing. Because it is. I mean, it's a $3,000 amplifier. Plus. Auto everything. Amazing piece of kit. Well, on antenna B, let's go to 160 and let's put it through its paces. So this amplifier was built for a different time. It was built in a time when there was, you know, your transceiver did 100 plus watts, about 100-ish watts. I'm able to do 80 out of my little bench radio, which means we're going to see about 800 watts coming out of this thing, and we're going to see how it does across the band. It is set up to the numbers the way it should be. Yes, I could go in here and I could change the gate voltage and make it do more, but we all seen, you, me, everybody else, what happens when the gate voltage is too high. It ain't worth it. It's not worth it. Okay, so we're on 80. We've got here a 1,000 watt element in peak, 1,000 in average, and a 5 watt slug in reverse. Back from the good old Bird 10,000 watt dummy load. Hello, 1, 2, 1, 2. There's our 80 watts worth of drive. Hello, audio, audio. They can't hear you on 800 watts on 80 meters. You need help. You need help. Or, pardon me, 160. Let's go up down onto 80 here. Hello, audio. 1, 2, 1, 2, 1, 2. Power's all the way open. Hello, 1, 2. Hello, 1, 2. Oh, we're on AM. Look at that. Change modes of operation. Hello, audio. Hello, audio. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. All right, moving on up. Hello, audio. Ooh, it almost did 900 watts there. Hello, audio. We might be in the radio's band of operation. Let's see here. All right, so it's 7. Let's go on up to 10 megahertz. Oh, we're back on AM. Let's go to sideband. Hello. Ooh, hey. Doesn't like that. Helps got it on the right band and on the right antenna. Hello. 1, 2, 1, 2, 1, 2, 1, 2. Moving on up. 20. Hello, 1, 2, 1, 2. Hello, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. It's happy. It's so happy. All right, let's see here. No, gotta go down one. There we go. Hello, 1, 2, 1, 2, 1, 2, 1, 2. Let's pop on up, 18 to 21 megahertz. Go 18. Hello, 1, 2, 1, 2. Now we'll go 21 megahertz. Hello, 1 2 1 2 1 2 1 2 1 2 1 2. I have not seen the SWR come off of nothing yet. Hello, 1 2 1 2 1 2. It is what it is. Okay, now we're going to go 24 to 28 megahertz. Let's go 24 megahertz. 24 megahertz. Hello, 1 2. Hello, 1 2. We're on AM again. Sideband. Hello, 1 2 1 2. All right. Hello, 1 2 1 2 1 2 1 2 1 2 audio. 1 2 1 2 1 2 1 2. Hello, command 1 2 1 2 1 2 1 2 1 2 1 2 1 2. All right, let's go 10 meters. Hello, 1 2 1 2 1 2. Hello, 1 2 1 2. 900 watts on 10 meters. Now here's a band I don't normally go to. Hello, 1 2 1 2. Now we are way outside. I don't think I got a slug that reads up there. 6 meters. We're just going to have to roll with it. Because look at the meter movement here. Remember, the elements stop at 30. Focus here. There we go. Hello, 1 2. Hello, 1 2 1 2 1 2. Oh man, we're way outside of what the element can read. I know for a fact I don't have a slug that reads up there. So, I'm not going to spend any more time worried about it than that. Works great everywhere. Let's see here. Where are we? We'll just randomly pull up. Here. Hello, 1 2 audio. There is this thing on top the show. 1 2 1 2 1 2 audio. 1 2 1 2 1 2 1 2 1 2 1 2 1 2 audio. Hello, 1 2. Well, you know, Kevin, I got up this morning and wouldn't you know it, I had a hangnail on my big toe, and I had to call out across the house to old Martha and said, "Hey, Martha, come on over here and help me with my hangnail on my big toe." You know, so she got them funky looking pliers, you know, not the normal toenail clippers, but the kind for the big toe hangnail clippers. Martha come over and she put her hand all the way around my big toe and she pulled it right on up there and she said, "Oh, Fred, you need to wash your big toe." She got in there with the old clippers and she just went to clipping and clipping and clippity clapping and clipping it. Clipping and clapping and clipping it. Wouldn't you know it, after that, Martha took good care of that big old hangnail I had going on. No more, and it's all gone. Well, there you go, gentlemen. This is Fred signing off from the net. Back to the rest of you. Drop mic. Came in here not working, leaving here working 100% with the parts that it had in it. I didn't have to do a PA board swap. I just fixed the damn board. I get to go to bed tonight knowing way more about Tokyo high powers than what I knew when I woke up this morning. Gentlemen, my name is BBI, and I say a big shout out to Siglent, XS Power, Coaxial Dynamics, Bird. A big thanks to all of you guys. If you have found this video entertaining and you want to help support the channel, come throw us a little bit of love over here on Patreon. It is literally what pays me every day to sit here and talk on the phone for 3 to 5 hours a day, answering everybody's questions. Thanks, guys. And G-Man, it is on its way home to you. Have fun. Click, click.